In graph theory chapter, I already discussed graph terminology and special types of graph, representation of graph and graph isomorphism, connectivity, Euler and Hamilton path, planar graph. Next I will discuss graph coloring, and this is the last topic of graph theory. First, what is graph coloring? If we are assigning different color to vertices, there are two adjacent vertices not having the same color is called as graph coloring. So definition 1, a coloring of a simple graph is the assignment of color to each vertex of the graph so that no two adjacent vertices are assigned with the same color. One vertices is red color, then its adjacent vertices cannot be red color. So that is graph coloring. Next, definition 2, it's the chromatic number. The least number of color we can assign to a graph is called as chromatic number, and it can represent by xg. In Greek, this x called as g. Next, theorem 1, it's 4 color theorem. In a planar graph, maximum colors required is 4. You already know what is planar graph. If we can draw a graph in a plane without tracing of edges, it's called as a planar graph, and for planar graph, maximum color we need as 4. Now example 1, what is the chromatic number of graph G and H shown in the figure? These are the two figure, and we need to find what are the chromatic number of G and chromatic number of H. So first we will assign the color, and least number of color required for coloring this graph is called as chromatic number. Let me assign D as red color. If we are assigning D red, then A can be red and G can be red. A, D, G are not adjacent. We can assign B as blue. If we are assigning B as blue, E and C cannot be blue, right? So we can assign F as blue. B and F are not adjacent. We can assign C as green and E as green. C and E are not adjacent. Now you can see no two adjacent are having same color. So here A adjacent are B and C. B is blue color, C is green color. Both are different, right? So for graph G, we need 3 colors. The chromatic number of G is at least 3 because the vertices A, B, C must be assigned different color. B, C both are adjacent to A. If A is red, B, C cannot be red. If B is blue, C or A cannot be blue. Next we'll check graph H. If we'll assign red color to D, A can be red color, but there is a edge from A to G. So G cannot be red color. Let me assign green color to C. If C is green color, B cannot be green, E can be green. If E is green, then G or F cannot be green. Then I can assign B as blue, F as blue. Then I can assign brown or yellow, any other color for G. Here we need red, blue, green, yellow, 4 colors. So for graph H, we need 4 color. H has a chromatic number 4. So for graph G, at least 3 colors required. So chromatic number is 3. For graph H, at least 4 colors required. That's why chromatic number is 4. Here we need one more color as there is a edge from A to G. So due to this edge, A and G cannot have same color. So that's why we need one extra color. Next, example 2. What is the chromatic number of Kn? Kn is the complete graph. Suppose we have a complete graph of 3 vertices. Here let green, yellow, red. We need 3 color for a complete graph having 3 vertices. Let's take a complete graph having 4 vertices. So here one color can be red, then one can be yellow, blue, green. So we need 4 color for a complete graph having 4 vertices. In case of complete graph, all vertices are adjacent to all other. So that's why we need n colors for Kn. So how many vertices are there? That many colors we need. Next, example 3. What is the chromatic number of the complete bipartite graph Kmn, where m and n are positive integers? I already discussed bipartite graph. Let we have A, B, C. Here 1, 2, 3. So A is adjacent to all 1, 2, 3. B is adjacent to all 1, 2, 3. C is adjacent to all 1, 2, 3. This is a complete bipartite graph. M and N can be different. Here in both sides I took 3 vertices. There can be 3, 2, there can be 4, 5. It can be different, it can be same. Now let me assign colors. So for A I can assign green. For B I can assign green. For C I can assign green. Then for 1 I can can assign blue, for 2 I can assign blue, for 3 I can assign blue. So we just need two colors, one color for one set, another color for another set. In KMN we are partitioning the vertices into two groups. M is one group, N is another group. Here A, B, A, C are not adjacent, right? So all A, B, C you can assign one color. 1, 2, 1, 3 or 2, 3 they are not adjacent. So you can assign one color to 1, 2, 3. So in case of complete bipartite graph, chromatic number is 2. Next example 4. What is the chromatic number of a graph Cn where n greater than equals to 3? Cn means cycle graph. Suppose we have a cycle of length 3. Now one vertex can be red, green, blue. So here we have 3 vertices and we need 3 color. Let's take another example having even number of vertices. Let's have a cycle having 4 vertices. One can be red. This vertex also can be red. These 2 vertices can be green. So in case of cycle graph, if number of vertices is even, we need 2 color. If number of vertices is odd, we need 3 color. So chromatic number is 2 if n equals to even and chromatic number is 3 if n equals to odd. Next, application of graph coloring. Graph coloring have variety of application in scheduling and assignment. For example, scheduling the final exam. So how can the final exam at the university be scheduled so that no student has 2 exams at the same time? Or frequency assignment, how the television channels are assigned to station in North America so that no 2 stations within 150 miles can operate the same channel. So generally for scheduling or assignment we used graph coloring. Next example 5. Find the number of color needed to color the map so that no 2 adjacent regions have the same color. Till now we assign color to vertex. Now we'll assign color to region. We have 4 graph. We'll assign color to region that no 2 adjacent region have the same color. Now first graph. Suppose we'll assign A region as green. Then neither B, C, D, E can be green as all are adjacent to A. Let me assign B as red. If B is red, then C, D, E, anyone cannot be red as all are adjacent to B region. So let me assign C as yellow and E as yellow. Then I can assign D as blue. We need 4 colors for first graph. Next check second graph. If we'll assign A as red, C can also be red. If we'll assign B as green, then D can also be green, right? So we just need 2 colors for region coloring of this graph. Next third graph, if we'll assign A as red, then neither B, C, D, E cannot be red. Even nor F can be red. So no other region can be red. If B will be green, then D can also be green. B and D are not adjacent. If C is blue, then E can also be blue. C and E are not adjacent. Even F can also be green as F is not adjacent to B or D. Or even F can be blue as F is not adjacent to C and E. F is adjacent to A but not to B, C, D or E, right? So here 3 colors. Next graph 4. If we'll assign A as green, then B cannot be green but C can be green, D can be green, right? A, C are not adjacent, A, D are not adjacent. If B is red, then E can also be red and even F can also be red. F, E are not adjacent with B. With B, C and D are adjacent, not F and E. So here we just need 2 colors. For figure 1, we need 4 colors. For figure 2, we need 2 colors. For figure 3, we need 3 colors. For figure 4, we need 2 colors. Next example 6. Find the chromatic number of the given graph. We have 4 graphs. We need to find chromatic number for each. So now for figure 5, if A is red, then BC cannot be red but D can be red. Right? Now C can be green. If C is green, then B cannot be green. There is a edge between C and B. So we can assign B as blue. We need 3 colors for this. Next figure 6. If A is red, then B, F, G cannot be read. C, E can be read. C, E are not adjacent to A. If B is green, F can also be green. B and F are not adjacent. Both are adjacent with A. So both cannot be read, but both can have green. Now G is connected with all the vertex. We used red and green, so G cannot be red and green. We can assign some different color for G. Let me assign blue color. So here we need 3 colors. Next, graph 7. If we'll assign red to A, B and D both cannot be red, but we can assign red to C. Next, B we can assign green color, but D cannot be green, so we can assign blue color to D. Here also we need 3 colors. Next, graph 8. Let me assign blue color to C. If C is blue color, then A, E, F, D cannot be blue. All are adjacent to C, but B can be blue. Next, A I can assign red color. If A is red, E, C and B cannot be red, but F can be red. Next, I can assign green color to E and D. So total 3 colors I need. Example 6, for all graph we need just 3 colors. With this I am finishing graph coloring. In today's lecture I discussed what is graph coloring, what is chromatic number and 4 colors theorem with some examples. In next lecture I will discuss previous question of graph theory. If this lecture is helpful for you, please like, share and subscribe. Thank you.